In this video, we're going to talk about getting started with PrimeX, how to import data into a Maestro project, and how to perform a quick R-factor calculation. Now, Maestro is the interface to all Schrödinger software, including PrimeX. When we first get started with PrimeX, we'll usually begin with an empty Maestro project. A Maestro project is a collection of structures, surfaces, and other things associated with the structures that we're working on, as well as the output of the calculations that we perform. The first thing we want to do when getting started with a protein crystal structure refinement is to save a Maestro project, and then import our data. Working within a saved Maestro project means that we can essentially quit Maestro and restore it to the same state that we left it in when we resume our work later on. To save the project, we'll head up to the Maestro project menu and choose Save As. We'll type a name for our project, in this case, 1MPD Refinement, which is named after the example that we'll be using, and we'll click on the Save button. One important thing to note is that we don't need to manually save our project from here on out. All changes are automatically written to disk as we perform various operations. So if we ever want the option of returning to a specific intermediate point in our workflow, PrimeX provides a checkpoint utility that we'll review later on. Most PrimeX operations can be performed using the PrimeX Toolbar, which isn't displayed the first time that we start Maestro. To display the PrimeX Toolbar, we can head up to the Applications menu, choose PrimeX, and select Display Toolbar. This causes the PrimeX toolbar to appear here, near the top of the screen above the workspace. To the left, here, we have the Maestro toolbar, which can be used to perform many actions that aren't specific to PrimeX, like changing the appearance of a structure, displaying hydrogen bonds, or adjusting torsions. Hovering the mouse pointer over any of the buttons in either the Maestro or the PrimeX toolbar will display a text box that describes the button's function. If you want to dismiss the PrimeX toolbar, it can be hidden the same way that it was displayed. Another option under the PrimeX item in the Applications menu is Input Data. Importing crystal data will cause the PrimeX toolbar to appear automatically, and we can either choose to input data from the menu, or we can click on the Input Data button in the PrimeX toolbar. This opens up the Input Data interface, and there are a few files that we need to import. We'll be using the protein crystal structure 1MDQ as the molecular replacement model to solve the crystal structure known as 1MPD. And we need to import the molecular replacement coordinate file, the sequence file, and the reflection file. First, we'll import our molecular replacement structure by clicking on this topmost Browse button to open the file selection dialog, and we'll choose the file mrsolution.pdb and accept the default setting to use the current B-factor values. In this case, the molecular replacement solution differs from the protein that we're working on by 2 amino acid substitutions and 1 amino acid insertion. Next, we'll import the sequence file for the protein structure we're refining, 1MPD. We click on the Browse button next to the field for the sequence file name, and we'll choose 1mpd.fasta in the file selection dialog that appears. Finally, we'll tell Maestro to import our reflection data file, 1mpd.cv. When we choose the file, we're presented with options for choosing a random test set that will be used to calculate R-free. We'll accept the suggested values by clicking on the New button. At this point, the fields for space group and unit cell parameters have been filled in automatically. These values come from the coordinate file or the reflection file, whichever one was read last, and contains the appropriate information. The one final setting we need to apply is the resolution limit, which we'll do by clicking on the Calculation Settings button. This opens the Calculation Settings interface, and it's important to note that the settings we apply here will apply to all of the subsequent jobs that we run, although we can always change these settings later. At the top of this panel, we'll enter the resolution limit of 2.3 angstroms in the appropriate field. However, there's one more very important setting to be aware of. Include hydrogen atoms in structure output. PrimeX uses an all-atom force field for all of the back-end calculations, and when you give PrimeX an input structure that consists solely of heavy atoms, it will add hydrogen atoms to the structure in an intelligent manner, using a very fast algorithm that ensures proper hydroxyl torsions. For now, we'll disable the option to include these hydrogen atoms on structures that PrimeX returns, but we'll want to enable this option later in our workflow. We can accept our calculation settings by clicking OK, and we'll click on the OK button in the Input Data panel to import the data. Upon import, the structure will be added to the project table, which can be displayed and undisplayed using the Project Table button in the Maestro toolbar. We'll get started on our protein crystal structure refinement by calculating R-factors. To run an R-factor calculation, we'll click on the Selected Task button in the PrimeX toolbar and choose R-factor calculation to open the R-factor calculation window. Note that we see the Calculation Settings button in this interface, and if we open up the Calculation Settings window, we can see that our previous settings are preserved here. We'll retain these settings and close the panel. To perform the R factor calculation, we simply click the green Start button. This opens the ubiquitous Start dialog, which is common to all programs. We can set things like the host and number of processors to use for this job, but for now we'll just accept the default settings and run on the local machine by clicking on the Start button. When you launch a job in Maestro, the monitor panel appears automatically, and as your job runs, you can monitor its log file in this window. At the conclusion of the job, the results of the R factor calculation are automatically added to the project table. R factors are displayed here as a property in one of the project table columns. It's also possible to display R factors in the workspace. To do so, we'll open the Table menu in the project table window and choose Preferences. In the Preferences window that appears, we click on the Workspace tab and then click on the Feedback button to tell Maestro what properties we'd like to display as feedback in the workspace. In this case, we'll control-click to select the title, R, and R-free properties, and then click here to save our preferences. After dismissing the Preferences panel, we'll click in the workspace and press the S key to enable Workspace Feedback. And indeed, here in the upper left-hand corner, we see the structure title and R values for our initial structure. We'll use this structure as input for the next step in our workflow, which will add its own output structure to the project table. So, as we progress through our workflow, we can expect to keep a record of all of our intermediate structures here.